This is Trig Identities, part number 25. Now, what is it that many trig teachers will not teach their students? Well, first of all, how to break down that fraction. Okay. Now, let me show you how that fraction actually worked. Now, we're going to use real live numbers instead of what they did, okay? Now, let's say we have 12 plus 20 and 16 plus 40. Okay. Well, 12 plus 20 is 32, and 16 plus 40 is, of course, 56. And if you reduce down that fraction, you get 8/14. So, of course, you could reduce this down a little bit further, but we're just going to save it this way, all right? Now, it makes absolutely no difference if you divide every one of these terms by 4. Let me show you how that works. Well, what's 12 divided by 4? It's 3. What's 20 divided by 4? It's 5. What's 16 divided by 4? It's 4. What's 40 divided by 4? That's 10. Well, what's 3 plus 5? Well, that's 8. What's 4 plus 10? That's 14. As you can see, doing this is the same result as doing this. Same thing. Now, let's say we decided to factor out that 4 as 2 times 2. We could have put, and I'll just show you as an illustration here, instead of placing 4 as the denominator of all these fractions, we could have put done it this way. Well, the first thing we would do is multiply the 2 and the 2 together, and we would get 4, and then we divide 12 by 4, and we would get 3. So that doesn't change anything. See what I'm getting at? All right. Now let's say we decided to disguise this number and this number as the cosine of A and the cosine of B. Let's say instead of saying 2 times 2, we said the cosine of A times the cosine of B, and we did it with every one of these. Remember that cosine A and cosine B are nothing more than variables. Okay? They are literally numbers in disguise. You don't know what those numbers are, but you know that once you lift up that disguise, you'll find out what those numbers are. You can do that. So we turn this into cosine A, we turn this into cosine B. It doesn't change the equation. That's how they did all that. Okay? Now then, you say, well, that explains that part, but isn't there some kind of an illustration, some kind of a Euclidean proof, some kind of Ptolemy thing that you were talking about that shows us the tangent of A plus B? Not really, but kind of. Okay? We learned a lot in these videos. We learned about Ptolemy's theorem, Ptolemy's table of chords, the law of sine and cosines, which are both in Euclid elements. I showed you that. Okay? You've learned all that. So there actually is a way to illustrate this, just not the way you're used to. Okay? Now the first thing we're going to do is we're going to draw a circle. See that great big circle right there? Now, tell me if this looks familiar to you. Does that look familiar to you? Of course it does. Now then, what's the first thing we can do? Well, I'm going to go ahead and erase these letters here, and for a good reason, and I'll show you that in just a second. Now, doesn't that form a right triangle? Of course it does, because that angle right there is right. So we know this is A plus B right here. I'm going to go ahead and let's down here. Hang on. Boy, I do not like dry erase markers. You know why, too. Okay. So this angle right here is none other than A plus B. That has not changed. Okay? Now, you can say, well, isn't that line the sine of a plus b? After all, it's the side opposite over hypotenuse, and we already know that the hypotenuse is a radius, and it's 1. So isn't that the sine of a plus b? You got it. You got it. Alright, now I already showed you how to come up with the cosine of a plus b. Now then, what about tangent? This is important. What's a tangent line? That is a tangent line, right across there. Okay? Now then, what if we decided to extend this out like this? Well, eventually we would form a triangle. Now let me form this triangle a little smaller for you. Okay? So you can see this for yourself. We're going to draw a slightly smaller circle so you can see all this. Hang on. Okay. Here's the angle A plus B, like we've said. Okay, that angle has not changed one bit. We've extended out this line and we've extended out this line. Now, what was the first thing we said a few videos ago about tangent lines? We said that if a tangent line meets up with the radius of a circle like this, it automatically forms a right angle. Automatically. So that's a right angle triangle now. That whole thing is a right angle triangle. We already know what the length of one side of this triangle is. It's 1. That length is 1. We know that. Well, this radius right here is the adjacent line to A plus B. If you'll recall, the formula for tangent is opposite over adjacent. Okay? So, you say, well, that's the sine of A plus B. Well, you could technically say that, because after all, well, not really. You can't really say that's the sine of A plus B, and here's the reason why. Okay? Because this is not 1 anymore. Okay? This is the side opposite, but this is not 1 anymore. So that really is not the sine of A plus B. Okay? Now, you can say this is the tangent. Here's how that one works. Okay? So how do you say that's the tangent of A plus B? Because the formula for tangent is the side opposite over adjacent. We've already said this is the adjacent line to A plus B. We've already said this is the opposite line to A plus B. Well, if you divide the opposite by 1, what do you get? The opposite. That's all you get. Because any number divided by 1 is that number. So I don't believe you. Well, 14 divided by 1 is 14. 3 divided by 1 is 3. 256 divided by 1 is 256. That's just the way it works. So this line then becomes the tangent of A plus B. It's not the sine of A plus B. Although if you could figure out what the length of this line is, then you could have an opposite of a hypotenuse. But the thing is, this line is not 1 anymore, so this can't be the sine of A plus B. Doesn't quite work that way. But we can safely say that this definitely is the tangent of A plus B, because The length of this line divided by 1 is the length of that line. That's how we get tangent. So that is the tangent of A plus B, and that's how we got it. It's a right angle triangle. One of the angles is A plus B. There you go. All right. If you have any questions about any of this, feel free to leave them down here in the comments below. And the next thing I'm going to tell you is that unless I find something else, that is truly the end of trig identities. Okay, now there are other trig identities, but I think I can present them a little later on in something else. We don't have to go through all this. We don't have to have Ptolemy's theorem or anything like that. We've already seen how we get the sine of A plus B, the cosine of A plus B, the tangent of A plus B. You've seen all of this. You've seen illustrations and everything. You know what Ptolemy's theorem is. You know what Ptolemy's table of chords is. You now know that the cosine of A equals the cosine of negative A. You know all this. And you know this through Euclid, through Ptolemy, through Descartes. You've seen it all. These are the things that they do not teach you in some trig classes. You go to some of these trig classes, they'll never tell you this. But I did. Alright? That concludes my presentation. I will tell you more in a future video. Stay tuned.